Okay, let's take a look at the first couple from this worksheet here. And we have two elements that are going to be put in contact with each other. We have potassium and we have fluorine. Now to do this, we're going to need our periodic tables. So if you grab the two of your periodic tables and we'll kind of figure out how this works. Alright, our first element is potassium. And potassium brings how many valence electrons into play? 1. Why 1? Yeah, because it's group 1. And all group 1 elements have 1 valence electron. So here's K with its 1 valence electron. And we can see that fluorine is coming into the picture here, bearing how many valence electrons itself? 7, because it's group 17. We said in those P block group numbers from 13 through 18, all you have to do is subtract 10 from their group number, and that tells you how many valence electrons it has. So if fluorine is in group 17, 17 minus 10 is 7. All right, so we have F with 1, 2, 3, 4, 5, 6, 7. Remember, you have to put 1 electron per side before you start doubling up. Now, this one is relatively simple in the fact that we have 2 elements that fit very nicely together. Why? What does potassium want to do with its outermost electron? Lose it. Good. Because it has the choice. It can lose 1 or gain 7. And we all said that losing 1's a lot easier because it will look like a noble gas then. So it's happy to give it up. And fluorine, what does it do to become happy? It gains 1. So all we have to do is transfer that electron over to fluorine. And by doing that, we'll kind of do like this is before and we'll do an after. So after, K would be charged what? By giving away 1 electron. Yep, positive 1. So you can either put 1 plus or just put a plus. It means the same thing. And then fluorine would now have 1, 2, 3, 4, 5, 6, 7, 8. It has 1 more electron than it did a minute ago. So it would be charged negative, right? Or 1 minus if you want to write that. So we said the whole game here was to make sure they neutralize. And 1 plus and 1 minus definitely neutralize to 0. Okay, let's look at number 2. We got magnesium. Magnesium is an alkaline earth metal. How many valence electrons do those have? 2. Put 1 here, and it doesn't matter where you put the other one, I'll put it here. Okay, and to that I have iodine fly in, and it carries 7, just like fluorine because it's group 17. 1, 2, 3, 4, 5, 6, and 7. And we can imagine who's given up electrons in this relationship. The magnesium. So it gives up this one here to there. Is iodine now happy? Is magnesium now happy? No. Good. Because it still has 1 electron sitting there. And the only way to alleviate that and get rid of it is if I bring in 1 more iodine. Yep. So let's bring in 1 more. 1, 2, 3, 4, 5, 6, 7. And this electron's going to fly and join with that one. So now iodine has 8 around it. And magnesium lost the 2 in its valence shell. So that's our before picture. And then after, we're going to put the magnesium, we can put it in between the 2 of them, like this. We have I, and we'll put Mg right here. And whether you want to put it to the side or down below, it really doesn't matter, because in both cases, these iodines are going to be surrounded by 8 electrons. And when they did that, when they gained their electron, what did each iodine gain as a charge? Negative. Each one got a 1 minus charge. Okay, so I'm going to put a 1 minus there, I'm going to put a 1 minus there. Now, magnesium lost 2 in that action. So what is its charge? Yep, 2 plus. And then the whole, does it balance to 0? Does it make it neutral? Yeah, it does, because magnesium with its 2 plus charge versus 2 iodines, each one with a 1 minus charge, well, 2 1 minus charges is 2 minus, which balances out 2 plus. And that makes a nice ionic compound. All right, so do we get how this works? Any questions on that? All right, very good.